Tesla is quietly preparing the launch of Optimus Gen 4 with an astonishing target of selling around 10 million units. And projections for Optimus Gen 5 go even further, reaching an almost unbelievable 50 to 100 million units. The idea sounds outrageous, yet the ambition behind it makes it feel strangely plausible. Imagine a world where Optimus evolves so far that it becomes skilled enough to perform surgical procedures with a degree of precision even top human surgeons struggle to match. Universal access to a robot with flawless, fatigue-free surgical ability would completely transform global healthcare and redefine what medical treatment means. Every leak surrounding Optimus Gen 4 appears increasingly credible, and Elon Musk himself has stated that this generation will be so lifelike that people might have to gently prod to confirm it isn't a human inside a suit. Musk is no stranger to bold declarations, but this time, his claims stretch the boundaries of what people ever thought a humanoid robot could be. Optimus Gen 4 is not just being designed for simple household chores or factory-related routines. Its intended responsibilities will broaden significantly next year, even before its official public debut. For 3 years straight, Musk has consistently emphasized Tesla's long-term robotic vision, urging investors, employees, and shareholders to see the company as much more than a car manufacturer. He believes Optimus will eventually become Tesla's highest-selling product of all time. A Gen 4 unit is expected to outperform humans by 5 times annually thanks to its ability to work nonstop, 24 hours a day, 7 days a week. Musk has even confirmed that it can function continuously while plugged into a power source, meaning minimal downtime and nearly uninterrupted productivity. Once Optimus Gen 4 arrives, its visual realism and natural motion will likely shock the public. All mechanical systems, cables, and joint mechanisms are tucked away behind the robot's external structure, giving an appearance that closely resembles a living human. Rumors suggest the inclusion of an OLED facial display and deeply human-like hands powered by Grok-based voice interaction, though these features remain unconfirmed. Even the current Optimus 2.5 already shows early hints of this progress, performing martial arts-like routines fluidly enough to make some observers believe they were watching an actual performer in costume. It has held microphones at Tesla events and even served meals at the Tesla diner. Although impressive, these demonstrations barely scratch the surface of what Tesla aims to achieve. Gen 4 production could hit 10 million units, while Gen May 5th reach 100 million. Such numbers feel impossible at first glance, but anticipation for the upcoming Optimus Gen 3 reveals that each new revision brings another leap in ability. One of the most difficult engineering challenges is the robot's hand, which Musk admitted consumes more engineering time than almost the rest of the machine combined. The hand accounts for over half the cost of the robot, featuring 5 independently controlled fingers with differing joint configurations, powered by a dense array of actuators and muscle-like mechanisms in the forearm. These allow Optimus to grasp tiny objects like sewing needles or delicate eggs while still generating enough strength to lift heavy items. Mass production poses another enormous challenge. Musk wants annual production of 1 million units, yet no global supply chain for humanoid robots currently exists, forcing Tesla to build nearly everything internally through vertical integration. Musk also suggested that Optimus Gen 4 could eventually work in hospitals as a surgical assistant, a concept that initially sounds like science fiction, but becomes more reasonable when considering the robot's potential precision and consistency. A robot that works 8,760 hours a year, compared to a human's 2,000 hours, could maintain flawless performance in repetitive medical tasks, logistics, sterilization, and patient transport, provided safety systems are absolutely guaranteed. For now, Tesla is focusing on household tasks with Gen 3 and Gen 4 because winning public trust is the first step. While fictional portrayals of robots cooking meals or organizing kitchens have existed for decades, most people still find such abilities unrealistic. Yet Gen 3 might be the first household-capable robot to genuinely bridge that imagination gap. With 22 degrees of freedom in its hands and dozens of actuators mimicking human muscles, Optimus can slice tomatoes, prepare sandwiches, or apply pressure delicately enough to spread mayonnaise without tearing bread. Tesla's approach avoids the traditional method of programming robots line by line. Instead, Optimus learns autonomously by watching human videos, then practicing inside advanced simulations before transferring its optimized behaviors into physical reality. Gen 3 has been training in Palo Alto 16 hours a day using the system, learning new behaviors rapidly, from cooking breakfast to cleaning homes. The robot's navigation system builds its own indoor maps, identifies obstacles such as pets or cables, and responds to voice commands or even gestures. Pointing at dirty dishes is enough to make it start washing them. Simulation to reality learning forms the backbone of Gen 4's intelligence. The robot watches demonstration videos, runs billions of simulated attempts through reinforcement learning powered by Dojo, and emerges with highly refined skills. Recent internal demos show Gen 4 performing thousands of cooking tasks with both hands simultaneously, far surpassing earlier generations that could only handle simpler, single-handed routines. Hardware improvements amplify these capabilities. The upcoming AI 5 chip delivers massive compute power directly on board, eliminating cloud dependency and enabling huge neural models to run in real time. The redesigned Gen 4 hands, with over 50 joints and hundreds of sensors, react faster than human reflexes, detect texture and pressure precisely, and withstand tens of thousands of use cycles without maintenance. Battery life doubles, stability improves dramatically, and its gait approaches fully human-like speed, while rarely falling thanks to billions of simulated balance tests. Deployed robots share their learned experiences back to Dojo, creating a fleet learning loop that accelerates improvement globally. Tesla's factories already use early prototypes, giving the company a data advantage that no competitor currently matches. Production for Gen 3 is projected for early 2026 with prices between $20,000 and $30,000, scaling toward 1 million units annually by 2027. Applications will span elder care, household support, dangerous industrial work, mining, surgery assistance, and disaster response. Musk predicts that tens of millions of robots could eventually reduce global poverty by absorbing dangerous and labor-intensive work at extremely low operating costs. Environmental tasks, like planting trees or cleaning ocean debris, may also become routine. With all this in mind, the question remains: can Optimus Gen 4 realistically reach human-level dexterity, stability, and speed when current demonstrations still show limitations? Share your thoughts in the comments, and thank you for watching. Make sure to subscribe, like, and enable notifications so you never miss the next Tesla update arriving soon. As Tesla pushes forward into the era of advanced humanoid robotics, Optimus Gen 4 is shaping up to be the generation that blurs the line between machine and human functionally and visually, creating an entirely new category of everyday technology. The shift from traditional programming to autonomous learning marks one of the biggest turning points in robotics history, because these newer Optimus units no longer rely on rigid step-by-step instructions. Instead, they rely on a constantly expanding neural model that evolves through real-world demonstrations, simulation trials, and the collective experience of the entire deployed fleet. This learning pipeline allows each robot to instantly inherit skills discovered anywhere in the world, accelerating progress far beyond what any single human trainer could ever provide. The simulations themselves run on the immense computational power of Dojo, which processes countless digital lifetimes of trial and error for each behavior before it's introduced into the robot. With each update, Optimus becomes more coordinated, more intuitive, and more capable of adapting to unfamiliar scenarios, such as navigating cluttered homes, unpredictable weather conditions, or workplaces filled with moving people and machinery. The result is a robot that can shift from cooking to cleaning to organizing objects with natural fluidity, avoiding collisions, and modifying its movements according to the user's habits. Beyond domestic use, Tesla is also preparing Optimus for industrial flexibility, enabling it to handle logistics, assembly line work, warehouse operations, and tasks requiring precise tool handling. Musk has emphasized that the company's goal is not merely to build a humanoid robot, but to create a general-purpose worker capable of handling nearly any physical task that humans find repetitive, dangerous, or exhausting. As battery density improves and actuator efficiency increases, the robot's endurance, speed, and torque delivery approach levels that allow it to work seamlessly alongside humans on production floors. Tesla's plan for vertically integrated manufacturing, from motors to sensors to AI hardware, reduces long-term
Elon Musk
costs
is focused
and
on turning
ensures
the
the company
Tesla bot
controls
into a
every
machine
critical
that can work
component of the
non-stop.
robot supply chain.
While Chinese
According to
humanoid
Musk,
robots are still
the
fumbling around
economic
with flashy
impact of
energy-draining
widespread
demo
Optimus
moves
adoption
and collapsing the
could be as
moment the battery
transformative
runs
as
out,
the Industrial Revolution,
24/7.
but occurring at a much faster pace, leading to a world where labor shortages